All right, what's today? Happy Monday, everyone. Hope everyone had a good weekend. Man, yeah, I had a long day at work today. But welcome to Monday Night's Crucible. If you're new to the channel, Monday Night Crucible is where we learn how to code. We teach coding concepts, and we actually practice them using a website called exorcism.io. Sorry about that. So actually, I'll show it to you here. So we're going to be using this sweet website called exorcism.io to practice the things that we learn. And every week's going to be a new topic. We will. The goal is to get through every single exercise inside of exorcism.io. So we will be looping back. If you do miss a topic, we will be looping back for those things. So we will be hitting each of the topics, multiple times. So if you don't get it the first time, don't sweat it. Try to pick it up in the meantime, but we will be looping back. So we've done a few. I think last time, we did maps, I believe. And tonight we're gonna do math. Quick maths. If you've seen the Big Shaq song, you'll know where that's from. But we're gonna be using coding to be able to solve math problems tonight. So we're gonna pick some from the math category out of Exorcism. But as usual, I'm gonna give people a few minutes to kind of get logged on, get set up, and get ready to follow along. And we'll get going. If you don't, so head over to exorcism.io if you need to. I'll paste that in the chat. There, I'll leave that up there. Let's do that. So I'll get set up currently. Let's go back here. I've got a super short slideshow here. What in the world? Looks like the VM locked somehow. That's magic. I've never seen that happen before. But let me make sure we got everything set up here. We're going to go into our Crucible folder to get ready. Tonight's going to be kind of short too. There's a lot of math problems here, but we're just going to go over one or two of them. Maybe three if we get to them. I guess we've been doing a lot of easy ones. I guess tonight's the first time we're going to get into maybe one that's a little more difficult. Maybe we'll do, I did want to go over collapse conjecture. That's pretty cool. I thought the first time I saw it was pretty cool. Maybe we'll go over one of the simpler medium ones, like maybe sum of multiples. So you don't have to be worried about whether or not you're great at math. We're going to use the code to do it all for us and figure it out. Palindrome product might be cool too. Maybe we'll get to that as well. And also tonight we're going to be working in JavaScript. I usually work in Golang. I've heard some people say Golang was a bit intimidating. JavaScript allows you to kind of get going a little bit faster. So probably for the time being, I might hit Go every now and then. But I think I'm going to hit JavaScript and I'm going to start doing Python as well. I think those are kind of the most readable, easiest to get started with. To be honest, kind of easy to teach. You don't need a bunch of extra stuff in your files to kind of get going. I'm also finding that a compiled language is a little tough for people. You can't just kind of test what you have. You gotta do some weird stuff with Go for your package naming, etc., to kind of just be able to test snippets of code, or you got to hop in and copy and paste it into the Go playground. So we are going to switch to JavaScript today for that reason. That's what we're gonna do now. I'm gonna grab this easy one, this collapse conjecture first. Like I said, we're gonna do this one first, and then sum of multiple second. So let's hop into here, and I actually already have an answer up here because I tried this out a little earlier. I was going through them. Let me go back to math. I don't want you to see the math one. Where did it go? Let's reload the page. I'm actually gonna pull it off screen so you don't see it. Let me grab it from, can I pull it off screen? Topic, I went into the math ones to see how math difficult they were. So I don't want to teach you. I don't want to teach you any math problems, but actually we'll go into that second. Let me log into. Let's show you this first. Let's actually do I put together a super short slideshow, very simple. I didn't really need to do it, to be honest, but thought it might be easier on the visuals a little bit, but cool. So tonight we're gonna go over arithmetic operations. This is just doing math, using code to do math, and perform mathematic operations on numbers. So cool. So just a little bit about myself. Again, my name is Aaron Brooks. I'm a DevOps engineer at a software shop called Fearless in Baltimore. I also run this Twitch channel as well as a YouTube channel. Working on some videos for that now. Called MASTERMND. There are a few other things in store for MASTERMND. MASTERMND is going to be a little more than what this is, but the goal is to really get people interested in tech and help to get them jobs as well. So you can find me, you can check me out on my LinkedIn down here, /in/mastermind.io, or on any of my social media things at mastermind.io, except for YouTube. In the chat, you can type in !YouTube, I believe, and it'll give you the link from Nightbot. Because I don't really have any videos, so I don't have any followers, so I can't have my own custom channel name yet, but that's no big deal. So actually, I know what we're missing here. Let me get some music going. It's kind of boring. I knew something felt different. Cool, got the music going now. So cool. This is the only slide that we're gonna need to be able to do all the things that we're gonna do tonight. So arithmetic operations are exactly what you think they are. So one, we've got addition, and so we're gonna be using JavaScript, and in a lot of languages this is gonna be the same. But addition is going to be a plus sign. That's how you're going to do addition. Subtraction, minus on your keyboard. Same way if you were using your the calculator on your computer, no big deal. Subtraction, division is the slash. That might be one that some people don't know, but I think most people know that division is a slash. And then the bottom two are the ones that I really wanted to show you. And the only reason why I wanted to make this, and we should be able to solve all the problems or most of the problems in the math section by using these math operations. So modulo, this one's very important, and you will use modulo a lot for a lot of different things, and we will definitely use modulo tonight. Modulo is it's division. So if you do a number mod another number, it will do division, but instead of giving you the value of that division, it will actually give you the remainder. It'll give you whatever's left over. So if you were to do 10, if you were to do 5 modulo 2, 2 goes into 5 twice, and there's 1 left over. So that will return 1, and we'll do that a couple times real time so you can kind of understand what that is. You might need to. Oh, yep. You're right. Thank you. Appreciate that. Cool. Yeah, I'll leave it up in the corner for now. Appreciate that, Skull Crusher. So modulo is the is that operator, so it'll give you the remainder. And then multiplication. I think we know what multiplication is, but this is just how it's going to be denoted inside of JavaScript. Again, this is what we're going to be using tonight. Different languages do it a little bit differently. But I mean, actually, this is not multiplication. This is, I think that's exponents. Multiplication, you can just do a star, but don't worry about that. We'll do it real time. But that's all you really need. I just wanted to show you that those were the different math operations that we will be going over and that we'll be using to solve some of the problems tonight. So what I want to do first is let's head on over to exorcism. Let's see, JavaScript. Let me do this real quick. Let me try something. Give me 2 seconds. I don't want you to see the answer. I only did the, so actually log into exorcism, and then you can click the drop down. Go to the language of your choice. Doesn't really matter what language you use. We're going to be covering the topics on how to solve it more so than the syntax. And then just go down to math. I think there's math and mathematics in here. We're not going to do mathematics. I actually think mathematics doesn't actually show you anything. We'll just hit math for now. And then the first one we're going to do is one of the easy ones is Collat's conjecture. And then the medium one we're going to do tonight is the sum of multiples. So I'm going to put it on the starting screen so you can't see my answer while I get it, because I actually didn't do it on this computer. Actually, no, you can't see my, oh, maybe I didn't do it on this computer. All right. Well, I'll take that back. I thought the answer was in here. Maybe I never pushed it. But I did this a while ago. remember this being pretty easy, I think. But let's read through what it is. I'll make it a little bit larger. And let's bring this over here. Actually, let's download it first, and we'll read it straight from the README. But yeah, if this is your first time looking at Exorcism, once you click on it, an option, it kind of tells you what to do. Oh, man, it's like there's two different things in here. Okay. Well, now you can see the answer, but ignore that. We'll go through that together. I don't want to download the solution, though. I want to complete this solution. I'm not really worried about that right now. You can publish it, that's fine. Okay, cool. We'll use this download. So once you get the command line installed, you can just paste that into here, into your terminal. It tells you where it's downloaded, so we will change into that folder. I'm actually already in the Crucible folder. So this Crucible folder is actually a Git repo that I'm putting everything in. I could just make the Exorcism one a folder for the answers, but there's a lot of other files in there that I didn't want to mess with. So we're gonna put the answers in here, but we'll go here first and actually do our coding. All right, so let's open this up. Okay, it does have the answer file. So what I will do is I will just clear out the answer file. So another cool thing in Linux, this is this operator allows you to send whatever's on the left into the file on the right. So now when I open this up, it should be empty. So you can do this in Linux and Mac. So now that collapse conjecture.js file should be empty. Perfect. All right, let's open this up. Let's move my face to the bottom left since the pane is going to be open over there. All right, cool. Let's take a look at the README and read exactly what we're going to be doing. Let's preview it. So it's got some sweet formatting. Cool. Collapse conjecture. The collapse conjecture or 3x plus 1 problem can be summarized as follows. So that already sounds, if you didn't want to do any real math tonight, that does sound like it's going to be a little tough. I wasn't expecting to get 3x minus 1, or you may not have been expecting, but no big deal. Read through. These can be the types of things you will get on coding interviews or problems you might need to solve. And there's a lot of times where you need to do simple, relatively simple math problems like this to solve issues on your job. So we're going to take any positive integer. Let's make this one click bigger and make this a little smaller. All right, we're going to take any positive integer n. If n is even, we're going to divide n by 2 to get n divided by 2. If n is odd, we're going to multiply by 3 and add 1 to get 3n plus 1. And we're going to repeat the process indefinitely. And the conjecture states that no matter which number you start with, you will always reach 1 eventually. Awesome. So the goal is that we're going to have, it sounds like we're going to have two different things to do here. We are going to have to, one, make sure, actually, if you read into it a little deeper, and this comes with being able to read problems and understand them for coding challenges and interviews. It says take any positive integer in. So integers can be positive or negative. So this is telling us it has to be a positive number. So we're probably gonna have to do some type of check to make sure this is positive. And we'll check the test files to make sure of that in a little bit, but we're probably gonna have to do that. So if n is even, so that's the first thing. That's the second thing we're gonna be checking for. If it's the even number, we're gonna divide by 2, and then if it is odd, we are going to multiply it by 3 and then add 1 to it. So that sounds like we have 2 steps, and it sounds like the goal is we're going to do this until we get 1. It sounds like every positive number, if you follow this paradigm, you will always make it to 1. And then it looks like the outcome of this is to give the number in, give it a number in, return the number of steps required to reach 1. Okay, so the goal here is to get the number of steps. So what do we got here? We got an example here, and we're going to start with n equals 12. So let's work through this. So forget the code for now. We're going to work through this mentally and see how we can get down to what it wants. So it looks like the first step, we would pass in 12. we would determine if it's positive. It sounds like it's a positive number. Well, we know 12 is a positive number. In the first step, it looks like will give us 12. The zero step, basically, we're going to pass in 12, it's going to give us 12. So because 12 is even, 12 is an even number, we're going to divide it by 2. So when you divide 12 by 2, you go ahead and you get 6. Cool. And we need to run this process indefinitely. 6 is not 1. So we're going to run this process again. We're going to check 6. 6 is it's positive and it's even. And it looks, we'll never really have to check if it's positive again, but it is positive. It's even. Looks like we're going to divide by 2 again. We get 3. 3 is odd. So this is the first time that we are going to do something other than divide by 2. We are going to multiply by 3 and add 1. 3 times 3 is 9, plus 1 is 10. So that's how they get to the third step. And you can see here on the left, they're counting up the steps. And then, so that's even, divide by 2, so you get 5. 5's odd. Multiply by 3 is 15, and you add 1 is 16. And then that's divide that by 2, divide that by 2, divide that by 2, divide that by 2, and you always get 1. Very interesting. Cool. So we want to be able to do that and be able to count the steps here. So this is what we're going to do. Let's take a look at the test file. So, again, Exercism, if this is your first time checking it out, Exercism encourages test-driven development. It encourages TDD. And so test-driven development, TDD, trying to make that connection for you. This is a way of programming by focusing on the test first, writing the test before you write any piece of code. This allows you to better be able to solve the problem because you're coding to solve the test, and you wrote those tests to be able to solve the problem at hand. So these tests were already written. I didn't write this. This comes as a part of the Exercism package. And it makes it easy because it guides us. It tells us how to code, and it gets you better at, it's super overwhelming at first, but it teaches you how to read code for one, and to solve problems, using these tests. So it's pretty cool. So we've got this test here, this describe function here, and then we've got these tests. So basically, just a quick way to read these is everything that's a test is a case in here, is a test case in here, and it gives a description. So it's saying, hey, I want you to test that for 0 steps. There's 0 steps when 1 is passed in. That's a description. Description can be whatever you want it to be. This is a string. Try to remember anything in quotes is a string. And a string is just a list of characters all together. So this is just a description here of what the test is. And then it's saying that it expects 1 step when I pass in 1 step. When I pass in 1 to equal 0 steps to get to 1. 1's already 1, so it doesn't actually need to run through any steps to get there. And then we can take a look at the next test case. There's an X next to it, next to all these. These are disabled. We can run through and we can enable these as we are coding to them. So this is the one that's saying it's a description for, to divide if it's even, to divide if it's even, and it's basically saying, hey, when I plug 16 into the equation, or into your function, into your program, I expect it to give me back 4 steps. So you can just go down here and see how there are different test cases to cover a multitude of different things that could happen. Large number of even and odd steps. So this thing sounds like you'll get both even and odd numbers in here. And then it looks like these last two here, you take a look, it's saying expect when you plug in 0, that's going to actually throw an error that says, only positive numbers allowed. And same thing for when it passes in a negative number. So its negative value is also an error. So it says, hey, when I pass in negative 15, I also expect to see that there's an error that lets me know that only positive numbers are allowed. So cool. There's a lot of different things we have to do here. So, but this one's pretty simple. We can get through this one pretty quick. When you get this package, it actually won't have this file in it. So just create yourself a file. You can call it whatever you want. I gave it the same name, and then we can get started. So we're going to do this with a function. And the great part about this test-driven development is we know that our function is going to be checking against, our tests are going to be checking against a function called steps. So we know what to call our function. So we don't have to worry about that either. So let's go ahead and type in function, and we'll use VS Code to autocomplete right there, and we'll call it step, or is it steps? They call it steps. All right, and this function needs to be able to, we need to be able to give a number to it. So in all of these, it passes in a number, and it expects something out. So we need to be able to pass in a number to this function. So in the parentheses here, in the same way that steps, the function steps is called here, and then in parentheses we have a number, we're going to put a representation of that number here in the parentheses. So I'm just going to call it, we're just going to call it number. So cool. So we've created a function now that takes, that's called steps, and it takes in a number. And right now this function doesn't do anything. So a function is a reusable piece of code. This is how you usually program, is you write a function that does a small piece of repeatable code, and it can kind of be self-contained. It can be tested very easily, and you can use it over and over again. So the first thing we're going to do is we are going to let's do the simple thing first. Let's check if it's positive first. So very simple conditional here. We basically can use if number, and so for a number to be positive, it must be greater than 0. So we'll just use that. So this actually needs to be in parentheses, and that's my dog over there trying to get my attention. Should be all right. If a number is greater, if a number is greater than 0, if the number that we pass in, so again, this could be anywhere we wanted it to be. This could be my name, but we'd have to change this also to my name. This is just a representation of the number that's going to be passed in. That's why I called it number. Maybe a little bit easier to remember and read. But yeah, it's just a representation of the number that gets passed in. So if we pass in the number 10, this will get replaced by 10, and this will get replaced by 10. So we're going to check if it's greater than 0. And if it is, what do we want to do? If it is, we really don't need to do anything, honestly, because we kind of just want the program to continue. So we'll put that there. Or we could do it opposite, and we could do... we'll leave it like that. So if number is greater than 0, do nothing. And then else, if it's not, so else will handle any other case. So this is if is very simple. It's if, and then it's a conditional statement that this always will return either a true or a false value. And so if the number is greater than 0, it will return true. If it's not, it will return false. If it is true, it'll complete whatever code is in the block here, but we're actually not going to put any code in there because we don't want it to do anything. And then, well, we may want it to do something, but we'll keep it here for now. But if it's not, let's go ahead and throw an error. So in JavaScript, you can throw, I think you can throw a new error. That seems right. And then we can just stick in the error that they put in there, that they gave us. Cool. All right, so if a number equals 0, let's do a test here to make sure. We can test this small piece of code. So let's put in something here to let us know what's going on. So we'll say if the number is 0, we're going to console.log. And so console.log is how you get it to print to the screen, how you get JavaScript to print something to the screen. And we'll print this number is greater than 0. And then if not, we're going to error, and we'll run this function here. So we'll do steps, we'll call steps, and then we'll plug in some numbers. So let's start with 1, and we will save this, open up a terminal, and we will run it. So node. All right, so we passed in 1, and it lets us know. Let's put it right here so you can see. 1, it says this number is greater than 0. So we passed in 1. It got passed in. It replaced number here. Basically, this got evaluated to true, and so this printed out. But let's say we change this to -1. If we go -1, boom, we get an error, exactly what we wanted, and it says only positive numbers are allowed. Awesome. So now we can actually, now that we've solved the first piece of this, we've solved that that the integer is positive. So now let's add in our stuff for this. So if n is even, we can divide n by 2. Divide n by 2 to get n divided by 2. Let's start with that. Actually, yeah, let's start with that. I am going to actually put, we only really want to check for this once. We could actually put this logic in here. Actually, no, we'll put the logic in here. There's so many ways you can do this. This is probably the best way. So we'll put the logic in here. We can say if the number is, so how do we check actually if a number is even? We can check if a number is even. Very simply, we can check all even numbers. The thing they have in common is that they're all divisible by 2. So that's what we'll check for. So we'll say if number is divisible by 2. So this goes back to modulo. So let's bring that back up. And this is when you're going to get to use modulo. Where did I have that? So this is when you're going to get to use this percent operator here. And this is where it comes in handy. So I could, because this has to this has to default to a true or to a Boolean value, a true or false value, Boolean being true or false. You have to give it a statement that can reach that. So I can't say, hey, just divide number by 2, because that's going to give you a number value. It doesn't really tell you anything. But we can use if number, we can use the modulo here, modulo 2. So that's going to divide it by 2 and give us the remainder. And we're going to say if that is 0. So if the remainder, if you divide this number by 2 and the remainder is 0, then that number indeed is a positive number. And this is something that you may have to do often. So, keep in mind that's how you could do something like that. We're going to say so number modulo 2 equals 0. And so I did 3 equals here. You may be wondering why I did 3 equals. This is very important in JavaScript. 1 equals is an assignment operator. So this is how you basically assign a variable. You basically set whatever is on the left equal to what's on the right. 2 equals is an equality operation. So this would actually work. But this would mean that I could either put 0 as a number or an integer or 0 as a string. Both of these would result to true. So this would work for me right now, but we want to be as intentional as possible. And 3 equals matches on both the value and the type. So because this 0 is an integer, that means this will default to false if it turns into 0 as a string, because 0 as a string and 0 as a number are not the same thing. Cool. So basically, if number modulo 2 equals 0, we are going to do something. So what did it tell us to do here? It told us to, let's close this for now. It told us to divide it by 2. So then we can do number now equals number divided by 2. Cool. And we can do, we can add another console.log. We'll add it up here. And when this happens, we'll add a console.log, and we will print out the value of number, so we know what's going on. So you can use console logs to debug your application, figure out what's going on. So we've got some logic in here, and so let's see if it works. So let's make sure it still throws an error. I won't change the number in there. Boom, I still have -1 in here, so it does throw an error. And now let's change this to something like 4 and save that. Let's run this file again. And when I run that, you can see over here the output is down at the bottom to the left a little bit. It gives us 2, and that's exactly what we wanted. Basically, it checked this, and it said, hey, your number that you pass in, which is 4, is greater than 0. So I'm going to run the next snippet of code. Runs this, it says, hey, is number modulo 2 equal to 0? And so if you divide 4 by 2, it gives you 0, and it says absolutely. So it runs the next snippet of code. And so I'm saying that number, the new number, I'm taking the variable number, the representation of the number that I passed in, and I'm saying it now equals number divided by 2. And then I printed that out. So none of this would do anything. If I took out this console log, nothing would happen. And I can show you that here and comment it out, run it again. I get no output. The console log here is how we get our information. There are other ways, but console.log is mainly how you get your information. So we got to print out too. That's perfect. I can also show you a shorthand. I think in JavaScript this also works. I think you can go shorthand like this, I believe. Let's check that. That still works. So this is a shorthand. You can do the if you do the operator and then an equal sign, it's shorthand for number equals number divided by 2. So like the same thing if I did number plus equals 2, this would just add 2 to the current value of number, and then this one would just divide the current number by 2 and set the answer equal to the variable number. But that's just shorthand. Something to remember. I'll expand it back out because I find that is confusing to people who come back, who may come in late or go back and watch this later and may miss that part. So I'll leave it as number divided by 2. Cool. So we've got our part done here. So we can do the next piece. And actually, let's do the next piece. First, actually, let me show you what happens when you run a test. So we actually have we haven't written any code that actually solves anything that we need to do for a number of reasons. But you can run. First, I need to install the packages. So I'm going to run npm install. This will install the testing frameworks and things that we need that are in this this repo. I'll give that a second to install really quick. This is taking a long time for very simple. This is gonna be a very simple piece of code for how long it's taking. I think we just need Jest. I think it uses the Jest framework to test. But yeah, while that's installing, we keep going. I can show you once that's done. Let's read the next piece. Go back to the README. All right, so now we need to know if it's odd, we want to multiply n by 3 and add 1 to get 3n plus 1. So let's figure out how to do that code. So I have if it's not even, there's only 2 types of numbers, 2 types of positive numbers. There's 2 positive integers, 2 types of positive integers. There are even and there are odd. So I could do another else if statement that will do that. I can add another if statement below. But because of that, the same way we did the else here, I can just put another else because every other case will be an odd number. And we can do whatever it wants us to do here. So for all the odd numbers, we are going to multiply n by 3, and we're going to add 1 to get 3n plus 1. Cool. So else we're going to do number equals number times 3 plus 1. Pretty simple. Pretty simple. If n is odd, multiply n by 3 and add 1 to get 3n plus 1. So you could also do, I think you could do 3 number, just put a 3 in front and not use this. But I want you to get comfortable using these arithmetic operators. So yeah, we get number times 3 plus 1. It's important to note that I think it's important to note that JavaScript follows the order of operations. So make sure you put your pluses and things in the right location, because if I were to do something like this, try to remember, was it PEMDAS? Was it parentheses, exponents, multiplication, division, addition, subtraction, or whatever. But the ordering matters. Just know that people will kind of get confused over the multiplication and division. It is not It is not multiplication and then division. It is multiplication or division in order from left to right. I see people arguing about this over Facebook all the time, or LinkedIn, when people post those very simple math problems. But it's multiplication or division in order from left to right. So this, even if this was this, this would happen first and this would happen second because it is multiplication or division, not multiplication first because the m comes first. But yeah, we'll put it back to how it was. But you can fix the ordering if you do need to put something first with parentheses. Parentheses work, and parentheses is the first. The parentheses are the first option of PEMDAS. So anything in parentheses will get evaluated first. So that is important. That's your math lesson for today. Yeah, pretty important. Something easy, very easy to forget, once you're done with school, because you don't do things like this very often in your normal life, but you might have to in your coding job. But cool. So number is now going to equal number times 3 plus 1. And we'll go ahead and print out number here so we can see that as well. So let's save it. And let's run it again. What did we say our number was? Our number was 4. So again, that's still going to give us 2, but let's go ahead and pass in an odd number like 5 and not 2 because 2 is not odd. All right, and when we do that, we get 16. So when we pass in 5, what happens? It evaluates here, says it is greater than 0, so it drops down to here. It says that the number 5 is not, modulo 2 is not equal to 0 because it would actually be equal to 1 because, again, modulo gives you the remainder. So it drops down into this else statement. And it said number is now equal to number, which is equal to 5. So it says 5. Well, number is now equal to 5 times 3, which is 15, plus 1, which is 16. Awesome. We could try a few other numbers. We could do 3. Yeah, we could do 3. Let's do 11. So 11 obviously should be 11 times 3 should be 33, plus 1 should be 34. And we can run this again. And cool, it's 34. So we know it's only printing one time. So we know it's only running this block of code right here. It's only running one block of code. So it's doing what we want. And it's giving us the proper number. Cool. So what do we have now? Actually, first, let's go back to the testing stuff here. So now that we've done the npm install, you can just run npm test, and it tells you in the preview, in the README, what you can do to run tests. Tells you first to npm install, so you don't have to worry about remembering what I did there, and then tells you can execute them with npm test. So let's go ahead and npm test this, and it should fail. And we'll see. It'll tell you what happened. All right, awesome. One test failed, and it tells you which one it failed on. So we know that we have this 0 steps for 1, and it says it gives you there's a type error, and it tells us that it's not a function. It tells you that basically the steps is not a function. So that helps us debug the first piece before we go into to finishing up the logic. We want to make sure we can be able to run these tests, and it's not a function because I wrote this in a different file than the specs. So what we must do, there's a few ways we can do this, but the easiest way is we must export this function. And exporting this function allows it to be used in other files. And you can see here, actually, you can actually see here that we had to name this file this name because it is importing steps, which is the function that we wrote. So of the same name, so it's importing steps from, and this is just a notation for the folder that we're in. It's saying the current folder and collapse conjecture. You do not need to specify the file extension. It just assumes it's a JavaScript file extension. So it's trying to pull in this, and it's basically saying, hey, I don't have this function, and it's not working for me. So now that we exported it, let's see what happens when we run this test. Make this a little larger. Let's go to the bottom. Let's clear this, and let's rerun this test. Cool, and we still fail, as we should, but it gives us a different error. It tells us exactly what it expected. Expected is going to be in the green. Expected to get a value of 0, and you can see here in the test, and it's passing in 1, and it's expecting it to equal 0, but it received undefined. And this is another important step. So if it received undefined and we know we were doing some console.logs to get some values, why is it doing that? So all functions must, to get that, all functions don't, but if you want to return, if you want to get a value out of them, you need to return something. That's that return statement. So the thing that we want to return currently is number. So we can actually, we'll leave those console.logs on until we're done. And we are going to basically, the return command is just return, and we're going to return number. And so now these things that we're logging, we should be able to get those things out. So let's go ahead now and let's save that, and let's run our tests another time. And you can see how you can use these tests as guides to figure out what you need to do and to code a little bit better. So we'll run another npm test, and it still fails us. Let's see why. It gives us that information. Awesome. It expected 0, but it received 4. Why is it doing that? One, is because we have not implemented all of our logic yet. And two, we are, let's actually go back to the README. We are actually returning something other than what it's asking for. So, you know, we did all our cool logic and we did what it said and we got that stuff to print out. But what it wants us to return, it says it right here, return the number of steps required to reach to reach the number 1. So now we've got to add in the logic for that. You know, we need to give the steps and not the actual number itself. This needs to happen indefinitely. So 2 things here. It needs to happen indefinitely. It tells us here in the preview that repeat this process indefinitely. Whenever you see the words repeat, or whenever you see repeat the process, it's almost always a loop. It's always a loop to repeat a process indefinitely. There's a couple ways you can do it. You can do a while loop. I'm privy to for loops because I like Golang, and Golang only has for loops. So we can do this with a for loop or a while loop. And I think they're actually, in this case, they're actually going to be relatively the same, if not exactly the same. Cool. So let's do that. So we need to run this bit of code indefinitely. We want to run this logic indefinitely until the number equals 1. So we can nest this inside of yet another set of logic. So I'm going to do for, and I'm going to, there must be somebody outside. So we're going to do var, we're going to set a variable. So this is how you set up a loop. I haven't actually ever run a while loop in a long time. I don't know if it's set up the same way. Let's actually look that up. While loop JavaScript. Go has spoiled me. The simplicity of it has spoiled me. Okay, so this probably is easier. Let's try that. Let's try that out. Let's go with while. Let's see. Let's say while. Will this? Hold on. Let me see if this will repeat. If it'll take the number. Yeah, let's go while number is not equal to 1. Run the snippet of code. I think this will work. This may not work. We'll find out all together. Let's indent this. And let's add another thing here. Oh, actually not equal to 0. While oh yeah. So equality operators. Actually, let's keep this same. If you put an exclamation point first, that changes it from an equality operator to and it basically flips it, and it's saying is not equal. So it's checking. This statement right here is basically saying while number is not 1, run this code. So as long as this number is not 1, it should rerun this code and it should spit out some info. And so we can check this locally before running it against our tests. I'll take out the export because you cannot run, I don't think you can run an exported function from here. So steps, we're going to return number. we don't want to return number. We want to return actually, I like the for loop, but we can still use it with the while loop here. We need to set up a counter here, and I could set up the counter with the for loop, but we're gonna make a variable called count. And so this is gonna keep track. This variable is gonna keep track of the number of steps it takes to get to 1. So we're gonna go var count equals 0, and then we're just gonna add in here. We're gonna increment count every time this runs. So this is actually, I can put this outside of here. So basically, after either one of these runs, this is we're gonna increment the count number. So we're gonna say count plus plus. So this is again a shorthand thing. So this is the same thing as count equals count plus 1. This is shorthand in a lot of languages, in a whole lot of languages. You can just do count plus plus. That's the reason C. So if you've ever heard of the programming language called C, C++ is called C++ because it's the next iteration of C. It's one step up. It's supposed to be a better C. Most people don't know that. And then C# is a play on a couple different things, but it's supposed to be that sharp is actually 4 pluses, and so that's another increment. But yeah, you can use this for that, and this should this should add 1 account every time, and then we can do something else. We can console.log, and we will say count, just so we can see what it is. We can do count and print the number next to it. So this will just give us a string of count, and print the actual count number next to it, just for some formatting purposes. So it'll print out our number, and it'll print out our count. So let's save this, and we'll leave 11 in there, and we'll actually run the file instead of running the test. And we'll clear this out, and we are going to go run our command again. Cool. So we get some output here, and it ran without breaking, which is nice. On the first count, it gives us 30. It runs once. The initial count is 0. When it gets done, it gives us the value of number, so that we know number's not 1. It gives us a count, and we can see the count is incrementing by 1 every time it runs. So each of these is one section of the loop. And so let's take a look back at the code again. This while loop is saying while this statement is true, while number is not 1, run all this. So basically, it's evaluating against these two. It's saying, hey, if it's even, do this. If it's odd, do this. And then once after it evaluates that, it adds 1 to the count every time. So that's what you're seeing here. After each run, it spits out the number. It spits out one of these 2 console logs and tells us which count that was. And it goes through, and once it gets down to 1, we can see it gives us the count, and then it tells us that, and then it stops. So it knows to stop because once number is 1, it goes back up to run this while loop again. It checks if 1 is not equal to 1. It says, hold up, 1 is equal to 1. So I'm not going to run anything inside this. And then it drops out of all of this. So it drops out of here, and then it goes down to return number. And so it returns the number. But we don't want the number. We actually don't want to return the number. We actually want to return the count, because that's what our program is looking for. And we can delete this. And we can save that. And we can run an Npm test and see what we get here. All right, it fails. Let's see why it fails. It says it's not a function. That's simply because, if you saw what I said before, it needs that export, which we took out to do some local testing. Export that function and move a little bit faster here because the other one's a little bit harder, but we'll get through that. Cool. And now we can see our first test passes. We've completed that test successfully. We can go scroll back up and we can see what we want to see, even though there's nothing there. But it lets us know which test passed, how long it took. And the 5 were skipped, and there are 6 total. So what we can do now is we can go through. You can do it a couple ways. You can do it one at a time. Some people like to solve them one at a time. You know, run Npm Test, make sure it passes. If it doesn't, you know, look at your code, make changes to it so that that test can pass. And so it passed again. We got that passing again. So this is actually one test suite. And it says 2 passed, 4 skipped. And we can just run down the line, but I'm just going to go ahead for time's sake. And I am going to enable every test here. Save that. Npm Test. It's going to run them all. And awesome. It says they all passed. It gives me the output for all of them. It gives me the count, all that stuff. Oh, well, it actually shouldn't. That's only because we left in all those console logs. Let's clean up our code. We don't need any of this for debugging anymore. I need to enable Vim key binding so that I don't need to delete lines like this, or I need to learn the key commands for deleting lines in VS Code. And so let's save this, and let's rerun our test after we remove those console logs, and it shouldn't give us all of that output. Cool, just like that, they all pass. We are good to go. So we've solved the problem. We've coded this to meet the criteria of the tests, and we got to learn a little bit of math along the way. So we learned how to a lot of things here. We learned how to use modulo, which is probably the only arithmetic operator that people kind of need to learn about when they're coding. People kind of know about the rest. You know about addition, subtraction, division, multiplication, exponents, things like that. But you may not know about modulo, which, you know, so we went over modulo, which is the percent sign, and that returns the remainder. And then we also used a lot of things that we've gone over in previous streams, but we used comparisons here. So we used various equality operators here. We used conditionals here. So we did some if statements, some if else statements, which are a pretty common thing to do. If else's, we did a while loop to kind of loop through something continuously until while loops loop through this continuously until this condition is no longer true. So we got to do that, and then we got to learn about, you know, incrementing numbers in loops. Almost every time you do a loop, you'll have to do something like this, whether it be a for loop or whatever. We also learned how to throw errors and how to, you know, give out errors in your code and give a description of what's going on with that error. And we learned how to export functions and how to code to your Jest tests. So cool. So we did that. We got that one beat. Once you get all your tests passed, you can actually do exorcism. I think it's submit, and then the name of the file, class conjecture.js, and it'll go ahead and upload your solutions that you can find at the link that it provides. Cool. So we've done the first one. So that one was one of the easier problems on exorcism. And we can do a one that's a little bit harder, but I actually don't think it's that hard. I took a look at it. I haven't actually done it yet. But I gotta take a look at it. I think we can get through it fairly quickly. And this will teach us much of the same. We use a lot of the same things. It's a good segue into this, just because we'll use a lot of the same things to solve it. So this one we'll download and we'll look at the README, because it's good to get comfortable looking at the README of a file. So we'll take that. We will close this. We will paste this here. / sum of multiples. And we will open this up. Code. Awesome. So this is how you're usually going to get the files. You're going to look over to the left, you can see the files that the package gives you. And so in here we have, some Babel stuff, some ESLint that's going to check our stuff, the package.json. So this package.json for JavaScript files is the thing that tells, when I run that npm install command, this is a file that gets generated, or that you can generate to set all of the dependencies that are required to run your code. And so you just put some stuff in there, and whenever someone runs npm install inside of the directory that this exists in, it will go through and it'll install all of these things for me. Just Babel, all the other stuff, ESLint, excuse me. So I'll go ahead and install that stuff for me. And then we've got the README here. The README is going to tell you what's going on with this code, what they want you to do. So given a number, find the sum of all of the unique multiples of particular numbers up to but not including that number. So I do think that this needs to be edited. I read this before and I thought it was once I figured out what they wanted, and I only knew what they wanted by looking at the test actually, like the wording for this is actually pretty bad. But given a number, find the sum of all unique multiples of particular numbers up to but not including that number. That is not a good read at all. That is actually very difficult to understand. So maybe we'll understand a little more if we start looking at examples. That's usually how I do it, because sometimes these word problems are tough. It says if we list all the natural numbers below 20 that are multiples of 3 and 5, and so maybe it needs it. I feel like this all needs to be in parentheses, so you know that this is one whole statement and not this being just a random add-on here. And that's what was confusing me before. But if you list all the natural numbers below 20 that are multiples of 3 or 5, you get 3, 5, 6, 9, 10, 12, 15, and 18. Cool. So all these numbers are below 20. And they are multiples of 3 or 5. So you multiply something by 3 or 5, you can get all these numbers right here. And then so it took all these numbers, and it says the sum of these multiples is 78. So if you add up all these numbers, it should give you 78. I'm not going to whip out the calculator, but you could add those up, and it should. We're going to trust it. Give us 78. So it sounds like it's going to give us two things. It's going to give us a number that we want to stay below, and we want to say all numbers up to, find all the natural numbers up to this number, and then only select the numbers that are multiples of whatever other numbers we give you. That's what it sounds like. I didn't get that the first time until I took a look at the test here. So I will take a look at the test. Cool. And what do we have here? We have the same exact setup that we had before. We have the describe statement, and then we've got all the tests below here. Same thing. It's going to be importing the sum of multiples function from this file, sum of multiples, that should be in this directory. So first things first, let's take that and let's make our file. So we know we need a file called sum dash of dash multiples. I spelled that wrong. .js. Cool. We've already completed the first piece of this. We've already done that, kinda. We need to create a function called sum of multiples as well, but we'll do that in a second. But basically, it's saying up to 1. So the test that's described as 1. I'm assuming that means the number we want to pick all the numbers below. And we're going to expect that when we run that, it looks like that we're going to give it, if this is your first time seeing things that are in brackets, this is called an array. This is a list of objects or a list of items here. They're also iterable. Arrays are iterable, so you can kind of iterate. You can kind of run through anything in array. Whoa. So it looks like it's going to pass in an array. So this is actually one thing right here because it's in brackets. The comma separates them, and then it looks like it's also going to take an integer. So it's going to say, what are all the things that are below 1? That's what I'm reading this as. So all the numbers, the natural numbers that are less than 1. Actually, what are natural numbers? Are they just positive? So natural numbers are positive integers. Cool. And sometimes 0 as well. All right, cool. I don't know if they didn't show 0 in their example. Well, for this, it'll never be 0 because it looks like it's looking for multiples. So we don't need to worry about 0, but it is positive numbers. So it sounds like for everything less than 1, we're going to check if it's a multiple of 3 or 5, which obviously it's going to be nothing. So it's expecting that to be 0. So that makes sense. So then it is saying up to 3. So it's saying the limit is 4, but not including 4. It says it here. It says using multiples up to, but not including a particular number. That's very important to note. And that's why this test is called up to 3 and not up to 4, even though it's passing in 4. So the numbers, all the numbers up to 4 that are multiples of 3 and 5 are just 3. So 3 times 1 is 3. Because it's just 3, when you add 3 to nothing, you get 3. Okay, so that makes sense. Same thing here. So everything up to 10. Everything up to 10 that's multiples of 3 or 5 would be, what would that be? That would be 3. That would be 5. That would be 6. That would be 9. And that would be not 10. So let's take that 3 plus 5 is 8. Plus 6 is 12. Plus 9. Am I missing something? Plus 9 is 21. I can't do math. Let me look. Let's look at a calculator. See, and this is why I use computers to do my dirty work for me. So we'll bump with this calculator real quick. So we got 3 plus 5 plus 6 is a multiple of 3 plus 8. No. I'm just making sure I got all plus 9. That's 23. I can't do math. You see why I'm using this calculator while I'm writing code to do so. You can also see that you don't need to be a math whiz who can't do, I obviously can't do simple addition, and I do this for a living. So yeah, so don't worry about if you're struggling through this. You can get this. So yeah, so I think I got it. I think I understand what we're doing here. We're just adding up all those numbers, but it looks like this is what I was worried about. It looks like it's throwing a little wrench in here. And I guess this is why this is actually a medium problem instead of an easy problem. Because I think if it passes in the same data every time, it will be relatively simple to solve this. But it looks like we get a varying amount of data. So things that need to be multiples of 7, 13, and 17 here. And then also 3 here. Okay, cool. So let's start coding. Let's start coding to this. What is the thing that they want? They want the sum of these. So maybe we should start with a function first, obviously. And we need to call that function sum of multiples. So I'll just go ahead and copy this. And parameters. What is going to be passed into this function? What are we going to be passing into to mess around and do this stuff? And what are we going to be, manipulating? We can see from the test here, we're going to be passing in 2 things. We are going to be passing in an array, and we're going to be passing in an integer. So we can call them 2 things. I'll call the array. I'll call it multiples because these are the numbers. These are the natural numbers that are multiples of, we're checking for multiples of, or we can call this, let's call this naturals. Well, no, we'll go multiples. We'll call multiples. Make it easy. And then the other thing that's going to be passed in, you can tell 2 things are going to be passed into this by the comma. And so it looks like we're also going to pass in the max number, basically, or the limit number. So let's call it limit. All right. So we've got our function here. We're going to pass in a multiples array, and we're going to pass in a limit integer. Being a Go person, this is bothering me that I'm not giving it the type, and we don't know what the kind of type multiples are. But no biggie here. All right, so first thing we want, I'm gonna declare a variable here called total, only because I know we're going to want to be adding up. We're going to set it to 0. I don't need to do this. I could just do this, but I'm just going to do 0 because I know we're going to be adding some stuff up, and I want to start that. Cool. So first thing we can do is we did while loops before. Let's go to it. Let's go to a for loop. Let's go to for loop only because we did a while loop. And you can see the difference between them. For loops are a little harder to set up. And so we're going to go for var I. So we're going to set another variable up. This is your iterator. This is the number you're going to be using to determine. This is going to be a number that we're going to be adding to as the loop goes on. And so the goal here, actually, and we can put in some comments here so people know what we're doing, and so that you know what I'm trying to do here. I want to let's describe what I want to do. I want to run a loop the same number of times as my limit. So basically, if I have, if my limit is 10, I want to run this loop 10 times. If my limit is 20, I want to run this 20 times. So I want to run this loop. I'm using this for loop so that I can run this a specified number of times. And again, could use a while loop for this as well, but we are going to do this. So the first piece of your for loop is you declaring a variable or an iterator. The next piece I'm going to say is while I, and so while this iterator that I set up, while it's less than my limit, run this loop. So this is the conditional. So this little piece right here is the same as whatever conditional you put into your while loop. But that's the middle piece here. So there are 3 separate pieces. You set up your iterator. You set up a conditional. I don't have to use I here, but this is the condition I want to be true to run this. And then at the end of every run, I want to add 1 to I. So what is this saying? This is the setting of the iterator. It's saying basically as long as this is true, run this loop, and then once you're done running this loop, add 1 to it. So if I still have the other file open, this is the same thing I did where I added the count ++ at the bottom. Very similar thing right there. So cool. We've got ourselves a loop that should run up into our limit. So whatever we put in here, and we can test this actually. We can do console.log I. And for now, I'm not going to pass in. Actually, JavaScript might not break if I don't pass in the multiples. Let me check. And what if I do sum of multiples? And let's say I just pass, no, because that'll pass the multiples. So what if I pass in 0? But then I pass in, let's pass in a limit. Let's pass in 20. So this should take passing in 20 as the limit. And let's see what happens. Basically, this should run 20 times. And it should print out the numbers 0 through 20 or 0 through 19 or something. Let's see here. Let's go node. Sum of multiples.js. Awesome. Perfect. Starts with 0, goes up to 19. Why does it only go to 19? And why does it print out the number 0? 1, because I set I equal to 0 here. Very important. So the first time this runs, 0 is less than the limit of 20, so it prints that out. But it only prints out 19 numbers here because I said while I is less than limit. If I wanted to print out 22, I could say while I is less than or equal to limit. If I run that again, that'll give me 20. But that's not what we want because in here it says up to, but not including. It's very important. You got to read the words here. Up to, but not included. So we're going to get rid of that. And so we've kind of got our first part here. We're going to run this loop, as many times as the limit is. And so we've already got that set. So what is the goal here again? The goal is to take in this, and up to that number, we need to run some other logic. We basically want to check if, we basically want to check if the numbers are, what numbers are multiples of what else we passed in. This is very, very interesting. How are we going to do this? So I'm going to nest another for loop. I'm going to take away this console.log. I know that we're iterating over all the numbers here, but we also want to run some comparisons here. So we could do something like this. We could say, that wouldn't work, because that will only run once, and that is very interesting. So what do we want to do here? We want to let's see. Only because what I was thinking would only solve the problem for. It will solve the problem for 2 items, but we have more than 2 items in some of these. So we have 2 here. My original solution was going to do that. We need 3 here, so we're gonna have this. I'll put another thing here. Run loop. We're gonna run a new loop for as many items are in multiples array. So the things I'm putting in here are comments. Comments are good to document and to convey things to your code. The comments do not get run at runtime. They are ignored. They are for people. They're for you to read. They're not for the computer to read. And so I'm just sticking them in here so you can hopefully follow along with what I'm doing here. And we're gonna make another one, and we're gonna say for. We're gonna set up a different iterator. You can be as descriptive as possible with these. I used I before. I'm gonna use X. No big deal here. So while X equals, so we're gonna set X equal to 0, and then we're gonna run this while X. So as long as X is less than, we're gonna use something cool here. We use this in a previous video. We're gonna use this. This here is multiples.length. What this is going to do is this is going to check. Remember I said an array was an iterable list of objects or items items basically. Using .length is going to check how many things are in there. So I'm going to comment all this out just to show you what the .length thing does. And I'll make an array var array1 equals, and we'll put in the number 1, the number 4, number 7, and the number 9. All right, so there are 4 items in this list, and let's see what that length does. We'll print out array1.length. We'll save that, and we'll run this. Node sum of multiples. Whoops, I didn't call the whole file. All right, and so it tells us there are 4. So that's what .length does. It tells us exactly how many items are in an array, or in our case, since we're using an array, it gives us the length of the array. It's also important if this is your first time. The problem we're solving. The problem we are solving is sum of multiples on exorcism.io. And basically we're just taking, we're checking all the unique natural numbers under a limit number. And we're checking if what numbers in that set up to that limit are multiples of other numbers that are passed in. It's just really annoying. It's a really dumb problem. And then we're adding those together. So that's the problem we're solving. I actually paste it. I can paste it for you. Let's go with JavaScript. Topic. I probably should have posted it earlier. And this is a medium problem. And cool. Yeah, so we're on xsystem.io, and that'll give you my solution that I actually gave you the solution just now that I just pushed for that. But some multiples here. But let's go through and finish this out. We can. So that's what array.length does. It gives you the values. It gives you the length of the array. So let's get rid of this, and let's uncomment our function, and let's finish this out. So basically, we're running another loop here, and multiples.length. And so basically we're saying run this as long as x is less than multiples.length. So if we pass in, something that has 2 in here, the length will be 2. And as long as x is less than 2, it'll run. And so 1 to 3, it'll run as well, so that we know that it will that will catch everything. And we'll do x plus plus again, so we'll iterate here as well. And then we will, this is where we'll actually write our logic. And the logic here is actually pretty simple. Because it's a loop, we could just say if, this is, we're going to use that modulo operator again to check. And we're going to say basically if I, so we set up I here. And so I is going to be the number that's counting up to our limit. And we're going to be checking if that number itself is evenly divisible by any of the numbers inside of our multiples array. So because of the way I'm writing this, we're gonna have to check for each number individually. But in doing that, we don't want any duplicates. So if we have, so if the number's 20, we don't want it to add up 3, and then again, get a match for 3 again, because it's checked every number. Because if it's 3 and 5 or something for 15 or whatever, it'll be really super weird. So we don't want it to double up like that. So we're gonna do if I modulo whatever's in the multiples array. So we're gonna call the multiples array, and we're gonna say multiples of place x. So let me show you what this does. Actually, I should have left in what I had down here before. Let's make that new array for array 1 equals 1. Equals 1, comma 4, comma 7, comma 9. So we got 4 items here. But these are 0. So arrays are 0 indexed. So you can refer to each of these values by their place. The first place is actually a 0 place. So array at the 0 place, the value is 1. The array at the 1 place is 4. The array at if you skip over the 3 place, is 9. So if I do console.log array 1, and I say print out what's in the 0 spot, and I save that, and I run it, whatever's in the 0 spot is going to be equal to 1, because 1 is in the first spot. And if I change this number to 3, it should give me 9, because that is in the 3rd spot, which is really the 4th because it starts at 0, but it is in the 3rd spot, and we can see it did that. So that's how you could call item. That's how you can call and refer to items in an array. And so that's what I'm doing here. As this number increments, it basically refers to the spot. So the first time through, this is going to refer, this x is going to be 0, and let's uncomment this so it's more readable. The first time this runs, this x is going to be equal to 0. So it's going to call the first item in this multiples array. So if we pass in this one, the first item is 7, and it's going to call that. So this x will get set to 0. And so it'll be checking through. It'll basically be checking through all the numbers for that number 7. And then once that's done, it'll go through number 13 and then the number 17. And you can see how the first time it'll be 0, next time it'll be 1, which will move it 1 over in the array. And then the next time it'll be 2, which will move it over to the 3rd spot in the array. And we're going to run our comparison here, and we're going to say if I modulo, our number of the array, and we'll do this again, is equal to 0, and that's how you check if something is evenly divisible. And if it's evenly divisible, inversely, it has to be a multiple of a number. Then we're going to add that number to the total. So we can do total equals total plus total, which is super weird to write. It's basically saying the new total, the variable total will be now equal to the value of total plus, actually it's not plus total, that's total, plus I, plus the number that we want here. We actually want I because that's the number that is, that we are dividing. So that's the number we're going to add, but we can shorthand this in the same way that we've shorthanded everything else, and we can go plus equals. And this will set total equal to total plus I. So shorthand for that. And then this is all the code we need to write. So let me run the npm install. This is all the code that we need to write to do the logic. But there's one big piece after this, which is one line of code, but I want you to understand why I'm writing that piece once we get to it. I want to run npm install, then I'll run the code, and we can check this out. So actually, let's set this up so we can run it while the npm install is running. And let's take in exactly what they have here. Let's pass in something where we know what the answer should be and see if we get that. And if we don't, let's figure out why. Actually, there are a few things we missed. It's not all the code we need. I lied to you. So we need to remember I said in the first problem. So multiple limit array. That looks. That array map would work. Absolutely. 100%. It's a little weird looking at it in the chat window. At first thought that we can try to paste that in and see if that works. That does look good. And a few more weeks from now, we're actually going to get into some of the cooler ways of writing code. Right now, I'm keeping it very simple because we're still kind of just learning about loops and stuff. But I do like your arrow function there. I do like the array.map is perfect. I like the reduce. That I do think that will work. Maybe we can try to paste that to see if it would work. Let's run this and see what we get. So this is actually not going to print out anything. We need to console.log it. But we don't actually have anything that prints inside here. So when we run this, let's just run it. I won't tell you. Just we run it. We get undefined. No big deal. This is the same thing that happened last time. You may think there's a problem, but our function here, we actually haven't returned. We haven't returned anything. So what is it here that we want to return? We want to return our total, I believe. Is that what we want? Is that what this is asking for? The sum. Yeah, it's looking for the sum, which is going to be our total. And we're going to return total. Save that. And let's run this again and see what we get. And cool, we get 51. And is that right? Yeah, we're supposed to get 51, so that is great. Let's try. This one works, but let's try a larger number. Let's try these. Let's paste this in. All right, what were we supposed to get here? We're supposed to get 4,419, but we got 5,344. Now, I could console.log. I could put a console log in here so we could see, what it increments every time. And you would start to see that it's doubling up. It's basically doubling up. It's getting matches for, so like it basically runs through this and it's finding every multiple of 5. Then every multiple of 6, but it's also finding those same numbers again that are also multiples of 5, so things like 30. And then it's going through and do that with 8 as well. It's this problem lets us know that it only wants unique multiples, so we're not allowed to double these numbers up. And there's a very easy way to solve this, and it is by adding in a break. So what does this do? Adding in this break will allow it, once it gets the first match for the number up to the limit. So let's say we're checking if the number 5 is a multiple of whatever we passed in. So we passed in 5. Once it gets to this 5 and it gets a match, it'll break out of this and it'll iterate to the next number rather than checking 5 for all 3 of these numbers. And so and this becomes pertinent on, again, like the number 30. If it looped through, caught a match for 5, and we let it keep going, it will basically add 30 to our total, and then it would go over to 6 and then add 30 again to our total. So adding in that break allows us to exit this loop. A break allows you to exit a loop once a condition is met. And so once this condition is met, we will add a break to it. And let's go ahead and run this again. 4,419, which is exactly what we wanted. So let's go ahead and run our npm test. Cool, 1 failed, and now we can see what happened. Let's read what's going on. Failed on the very first one, and it's basically telling us the same thing we got before, type error. Sum of multiples is not a function. Let's take a look at our code, and why is it not a function? That is because we tried to import it here, but we did not do anything to get it out. The limit is inclusive of the 150. It's supposed to be it's supposed to be to 149. And it says it here. It wants the unique multiples up to, but not including the limit. So it's 1 to 149. We've imported it here, but we didn't export it anywhere. And we'll go ahead and we'll export. And let's run our code again. And we passed. It passed the first test. It skipped all the rest because they're all X'd out. And that looks looking good. Let's go ahead and add in the rest of our tests here. I'll do them all at once. And there's probably an easier key binding, but I do like VS Code a lot, but I don't know many key bindings for it. I know my Vim key bindings, but I use VS Code almost every day, so I should probably take the time to learn the VS Code key binding so I don't have to do stuff like this. This is very annoying. Cool, let's save that. Let's save our test file. Run our test again. Boom, and they all passed. So we can go through here. And you can see they all passed, no matter what it was thrown in there. We could throw in our own test case here for like a bunch of things. Like maybe we wanted 20 things in here. I'm not going to do that because I don't know what the expected outcome is supposed to be. But yeah, you can use the test case to cover, all the things you want to test. And then you can run this test suite periodically, or every time code is committed, to make sure, as your code changes, to make sure it still works properly. So that's why these tests are cool, and it's cool coding to them. But I'm gonna see if this, I'm gonna paste in Womp's answer here and see if, let's see if it runs. Let's see if it formats it right. Let's go test.js. Whoa. All right, it's here. Well, it did it in one line. Still might work. I could. Well, it's a one-liner. But if I set it as a constant, I can just run. I'll run this. Because it's not going to I think I could do it the same way. Let's pass in same thing we have here. Let's try this one. Copy 220. Let's try to run that. And is that right? Awesome, you did that right. That's perfect. So you can see how easily, and actually let's look at that code side by side. And maybe this is a good opportunity to break that down some. I thought, hold on, did you try to post a, I don't know why it did that. We did do it. I'll fix Nightbot. I fixed Nightbot's links posting error last time. So I will adjust the spamming thing. That was annoying. Sorry about that. Yeah, so we did it, and let's break that down. Let's put these snippets of code side by side. Where is, man, my shoot. Cool. So you can see how this was made in one line, and then we actually set this to a constant. This is a way you can also declare functions. A constant is like a variable, but it's a constant. So a constant can be changed. Actually, the contents of it can be manipulated, but it itself, the structure of it itself, cannot be changed. Which is pretty interesting. That's something that I actually just learned recently, because there are other languages where constants. Some languages constants are just pointers basically, and some, like, you can't change your constant at all. So that was new to me a little bit, but same thing. We are just like over here. We are passing in our multiples and our limit. And this is an arrow function. This is how we push this to a function and declare our function instead of writing the function paradigm. And this is in Go. This is called this is using a variadic function. Variadic meaning any number of arguments. It may be called something different here, but I'm pretty sure that's what we're saying. We're saying we don't know how many we're going to get, but you can pass in any number of them up to the limit. JavaScript calls that array spread syntax. Okay, that's awesome. That's good to know. Array spread syntax. Yeah, so that means you can pass in kind of any number here and spread it up to the limit. And mapping. So mapping is going to basically allow you to declare a function and run that function on each item in an array, and basically plug it back into the same spot in an array. I'm pretty sure. And then we are filtering out, I think, the multiples here. Yep, we're filtering out any numbers that double up, which is pretty cool way of doing that. Yeah, and then this is where we're actually, doing our modulus here. Yeah, this is cool. This is very cool. This is an easy way. This is a good way to do it. Much more readable to me. This might be a little confusing if this is your first time, or you're early in your JavaScript career, I guess, or learning JavaScript. Yours will probably look something more like this, and we will definitely start throwing in a lot of these topics and a lot of the usage here. Definitely arrow functions. We're gonna start doing arrow functions for almost everything. Definitely gonna start passing in some of these methods, the dot filter, and I like the dot includes. That's pretty cool. Thank you for that. Yeah, so we've done two different ways to solve this. Actually, can I? Well, I was gonna try to switch it up and export that and run a test against it, but that's too much work, and the stream has been going on a little while now. So yeah, appreciate it. So we got done with two problems today. So hopefully you learned a little bit about how to solve math problems, basically. How to solve math problems using a coding language. Again, you can use any language to do this. I want you more so to understand. Don't worry about the syntax here that much. More so worry about kind of what we did. More so worry about, remembering what modulo does or modulus, and kind of understanding the concepts of how we're solving this, because as you can see here, you can solve it in two wildly different ways, and different languages have different tools available to them that allow you to solve it in different ways. And once you kind of understand the concepts, you can use any language to do so. So yeah, thanks for coding with me. I'm gonna push this stuff up to GitHub. Actually, let's do that right now before I forget, because I think I forgot last time. Let's push this stuff up to GitHub so that you can take a look at it. If you do a question mark, if you do exclamation point GitHub, you can copy the GitHub repo. It's one of the commands you can do. But let's copy sum of multiples.js into our Crucible folder, and let's copy / collapse conjecture into our documents Crucible folder. And let's go into our documents Crucible folder. I forgot there's a JavaScript folder in here. So copy star.js into the JavaScript folder. I shouldn't have copied. I should have removed. I should have moved, but I'm gonna move those. Let's make sure they got in there. Cool. And we can do git status. You guys can see this sweet git rocket shoot off. I think it works on here. I think I have it installed. So we're gonna add these. Get used to running git status. Get comfortable running git status. Git commit -m. We are gonna say we completed sum of multiples, and collapse conjecture problems on exorcism, and we are going to push that up to master branch. Cool. There we go. You can see the rocket taking off, and we've pushed our code up to GitHub. So you can, I think I can do it. I think I can do GitHub. And so you can check it out there. And you can pull down all the code that we've done from the Crucible if you want to just check it out and see what we did. I'll rename the test file and push yours as well. Well, thank you for that. But yeah, hope you learned something tonight. We will be back. I'll be back on Wednesday. Wednesday we're doing, for anyone new, Mondays are the Crucible. This is when we learn how to code. This is when we go through coding problems. We're going to try to complete every problem here on Exorcism. On Wednesdays we do cloud and system stuff. So right now we're in the middle of a Linux, a zero to hero Linux, series. This will be part 3. I think we did some basic command line, like installation and basic commands. Last time we did a whole list of things, process management, commands, disk space, things like that, memory. And Wednesday we'll dive a little deeper. We'll start to get into some of the advanced stuff. Just teaching you how to use Linux, teaching you how to administer Linux, because it's important in whatever avenue you get into tech. But yeah, that's what we'll be doing for at least another 2 weeks with that. So tune in on Wednesday if you want to learn some of that stuff. I was supposed to be giving away. I lost it and then I found it. I have it completely unopened. What is it? Amazon Alexa Mini that I got from doing an event with Amazon. But I will be giving that away once I find it and figure out how to do this Nightbot giveaway thing. One of these weeks. So if you're a follower, you will be entered to win. If you're a follower, so definitely follow. If you are a subscriber, if you want to use that Amazon Prime subscription to subscribe, you get 5. You have 5 times the chance of someone who's following me to win. But yeah, it's brand new. It's one of the new Alexa Echo Dots or whatever. I'm a Google Home guy myself, so I'm pretty ingrained in the Google ecosystem, unfortunately. So that's my jam. So that's why I'm giving that away. So definitely, tune in for that. I'll reach out to whoever wins that. But yeah, thanks for tuning in. I'll see everyone on Wednesday. Have a good night.